All right, so what I've got here for this one. Now let's go ahead and graph it. If you recall from this, I've got cosine going through this entire thing from negative pi to pi. So let's go ahead and graph this. I'm going to pause it for a second. I'm going to kind of clean this up a little bit. All right, so I went ahead and I drew a graph right on here that would represent cosine. And I went ahead and drew a couple periods of it. Obviously, as I've always said, I'm no artist. But what I've got right here, if I look, cosine normally goes from 0 to 2 pi, right? But what we've done with this particular graph is we've taken it, and so instead of being from 0 to 2 pi here, now it's actually 2 pi over 3. Because again, my b in this equation is 3, so it's 2 pi over 3. And so then, again, this isn't going to end here at 2 pi, and this one won't end at 4 pi over here. Instead, this is going to be 4 pi over 3. The reason I know that is because it's just 2 pi over 3 plus 2 pi over 3. And so then this is going to be negative 2 pi over 3, and then over here to the side would also be negative 4 pi over 3. Okay, and so really what I'm looking for is I'm looking for between negative pi and pi. Well, if this is negative 2 pi over 3 and this is negative 4 pi over 3, halfway between there would be negative pi, because that's negative 3 pi over 3, right? So now here I'm going to have positive pi over here. So the question to you, and hopefully you know this because you should, is it's going to be, where is the pi located? So if 2 pi over 3 is a maximum and 4 pi over 3 is also a maximum, that means that pi, 3 pi over 3, is going to be a minimum, okay? And so basically I'm looking right here at this part of the graph, from this minimum all the way to this minimum. That's what I'm looking at, okay? And so now I need to go ahead and locate these specific spots, which, not gonna lie, this is probably the more challenging part if you'll think about it this way, but it's not, because we're not having to actually be exact. We're going to have to be a little bit approximate, if you will. So if I think about where pi over 18 is located, well, if I'm thinking here, if I've got 2 pi over 3 there, that means that also, again, a minimum would be right here at pi over 3. I'm going to take that pi over 3, or actually I'm taking this pi right here, 0 to pi, and I'm just splitting it up into 18 pieces. Well, I've already divided it up into 3 pieces, so that just means that I need 6 pieces in between 0 and pi over 3, right? Because now between pi over 3 and 2 pi over 3, if I do 6 more pieces, that's going to get me another 6 more pieces here. That's 18 little tick marks between 0 and pi. Well, shoot, that's not too bad. Well, right here then, that would be my pi over 18. And then I'm looking for my next one that I'm looking for here. So I've got pi over 18, 13 pi over 18. Okay, so, well, here was 18. So I need 13, here's 12, so there's 13, just off the side here. Huh, those are in the same spot. Oh yeah, because they're exactly a period apart. Now let's look at this one over here. If I'm going to do negative pi over 18, that's going to be right here. So look at this. Once I found my 2 spots on one part of a graph on one period, I now know where they're at every time. They're going to be here, here, and they're going to be kind of up here in this little section right here at the very tippy top of my curves that I've got there, okay? So I've got my 6 locations marked here, 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 and here, okay? And so now if I go back to my inequality that I need here, I need it to be greater than, okay? So I'm just looking for the little spots between these markings. That's it. That's all I got. Those little spots between there, okay? So the way that I'm going to take my answer and go ahead and write this one out, again, because it's greater than, not greater than or equals to, just greater than. So I'm going to start with my furthest left point that I have. And that is going to go ahead and be at negative 13 pi over 18. So I've got negative 13 pi over 18, comma, and that's going to be this first one right here. And then I'm going to go ahead and go to its next one, which is going to be negative 11 pi over 18. What did I just click? Negative 11 pi over 18. It's not going to equal it because this is less, or I'm sorry, this is greater than, not greater than or equals to, union. And then I'm going to do my next one. So my next one would be negative pi over 18. So negative pi over 18 to pi over 18. And then I'm going to do another union. And then I got my last ones, which will be 11 pi over 18 to 13 pi over 18. There we go. And now I'm done. Needless to say, the ones that have multiple angles, those are rough. Okay. All right, now this one. All right, so now I've taken my sine graph, and what have I done with this graph? I have shifted it left, pi over 3. So I'm going to have to think about that, okay? And I'm just going to I'm going to draw a little sketch for you to think. All right, so you can see this little sketch that I've got here, and this should look familiar to you as a graph of sine between 0 and 2 pi, right? But now I'm going to take this graph and I'm going to shift it left. So I've got my original parent function there in the green, and now I've shifted my graph left, pi over 3, okay? Now, when I do that, and I mean, this isn't drawn to scale or anything, I'm just kind of trying to show you here. When I do that, if I look at my original one and I think about when does sine equal 1/2, well, it equals 1/2 at pi over 6, and then again at 11 pi over 6, right? So if this was just between 0 and 2 pi and hadn't been shifted at all, pi over 6 and 11 pi over 6, oh wow, that would be cosine. Man, I'm sorry, y'all. It's late. My brain's on other things, and yeah. So at pi over 6 and instead 5 pi over 6. Okay, so I'd have those two spots. Those two locations here, when I shift my graph left, they went from there, and you can see now at least one of those is no longer going to be a viable option. And so instead now what I'm going to have to do is I now have another, why is it doing that? I now have another period of my graph that I can actually just kind of place right here. And so I'm now going to get another one of those solutions that is now going to come here, okay? And so I'm getting that simply because all I've done is shifted my graph left. And so here, right there, it's not an asymptote, I'm just kind of marking it there. So you can see that's where that 2 pi marker would be. And so that's why this one has been shifted left, because this one was moved out. So whenever you move one of those values to the left or right, whenever you move it out of your range to the left, you're going to bring another one in from the right. Whenever you move one to the right and you move it out of the range of the values that you should have, then you're going to have to pull in another one from the left, okay? So in this particular case, when I go ahead and solve my equation here, I've got sine x plus pi over 3 is greater than or equal to 1/2. Okay, so I'm going to have to inverse right away because it's already isolated. So now I have x plus pi over 3 is greater than or equal to the inverse sine of 1/2, which I already said was going to be pi over 6, and our other one would be 5 pi over 6, right? Well, we already know based off of what I just drew that pi over 6 isn't going to work for us. So we've got 5 pi over 6 that will work. So instead, what I'm going to go ahead and do is I'm just going to go ahead and add 2 pi because that's what my period is. I'm going to go ahead and add 2 pi to pi over 6. So I'm going to add 12 pi over 6 because that's equivalent to 2 pi. And so now I have 13 pi over 6. So instead of doing pi over 6, I'm going to do 13 pi over 6. I'm going to look right there, okay? So I'm going to go ahead and subtract pi over 3 from both sides. So when I do that, I'm going to get x is greater than or equal to. When I do 5 pi over 6, let's go ahead and write it out. Minus pi over 3. When I do that, I'm going to have to get my common denominator. And so now I'm going to do 5 minus 2, which is going to get me 3 pi over 6, which that reduces down to pi over 2. Okay. All right. And then now for this one right here for 13 pi over 6, I'm going to do 13 pi over 6 minus pi over 3, which again, common denominator, 13 minus 2, so that's going to get me 11 pi over 6. Now do you know why I was saying 11 pi over 6 earlier? I was looking at the wrong spot on my notes. So if I do that, I've got my answers right there. All right, so I just got my answers for where these values are located at. So again, I'm looking at this one right here, and I'm also looking at this one right here, okay? And I need to know when sine is going to be greater than that. So greater than that is going to be all in this area. Oh, and that highlighter doesn't work on the black screen. It's going to be all right here and all right here. Okay. So what I've got, if I write that as an interval, it's going to go from 0. It includes 0 because this is greater than or equals to. So I'm going from 0 to, which one of these was my first one? It's going to be pi over 2. So it's going to go to pi over 2. It includes that again because it's equals to. And then I'm going to have my union. And then it goes to my next one, which is going to be at 11 pi over 6. To 2 pi. And it does not include 2 pi. All right, so that would be my solution there. So, I mean, with all of these problems here, I'm just going to go ahead and say that this is new for any of us teaching this class. We've not done this before. It is quite different. You know, the first time I looked at this, I thought it was really complex and challenging. I mean, it definitely is a challenge, but it's getting easier the more I do it. And I know you guys are not going to like this initially. I got one more video coming.